Hello, grade 11 A-level students. Right now, I'm going to explain about the chlorination of benzene molecule. The chlorination of benzene molecule basically is the same as the bromination of benzene molecule. In order to substitute chlorine into the benzene that replaces the hydrogen atom in benzene, this must use a catalyst, strong catalyst which is known as aluminum chloride. While in bromination of benzene must use aluminum bromide. The intermediate reaction would be the same. So aluminum chloride will make the chlorine molecule to break into the electrophile, and the nucleophile will be attracted to the to the aluminum chloride. This chlorine electrophile will be attracted to the benzene ring, and then that will displace the hydrogen atom. In order to achieve stability in benzene molecule, the electron of the hydrogen will be given into the structure of benzene. That makes the hydrogen will move out as an ion that combines with the chlorine, then becomes hydrogen chloride. And then now the second, I'm going to discuss about the nitration of benzene. Benzene will undergo reaction with nitrate. The condition, it must use extreme catalyst, which is concentrated sulfuric acid, and also in the presence of the nitric acid as the reagent. This nitric acid will react with the concentrated sulfuric acid to become nitrate electrophile. This one, we know that nitric acid and sulfuric acid, both of them are acid. But despite of the acidity of both, one of them will behave as an acid and the other one will behave as a base. As Professor Lowry said, that acid is proton donor and base is proton acceptor. The condition for this nitration of benzene is the temperature less than 55 degrees Celsius. And then the side product of this one is water. And then further nitration of dinitrobenzene, also some oxidation can occur unless the temperature is controlled to be below 55. The role of the concentrated sulfuric acid in this reaction is to produce the powerful electrophile. Just like in bromination of benzene, the bromine become a strong electrophile that can attack the benzene molecule. Also in this one, the nitrate will become powerful electrophile that can attack the benzene molecule. This is the analogy, the same analogy, and then we might expect the nitration to be NO2 positive. So this is already become the electrophile. The electrophile will react with the benzene to form this one. Okay, let's see next. Over the years, various pieces of evidence have been collected to substantiate the claim that nitrate, known as nitryl cation or nitronium ion, to be the electrophile. Stable salt containing nitryl cation exists. For example, nitryl chloride. This is the compound, and also nitrile tetrafluoroborate. Each of these, when dissolved in inert solvent, the nitrates benzene smoothly and in high yield to give nitrobenzene. So this is we have to make first the salt, the stable salt of nitrate, this both, and then dissolve in inert solvent. What is the meaning of inert solvent? Inert solvent means the solvent that does not react. What is the example of inert solvent? Is the organic. And then this one, the infrared spectrum of compound tells us the type of bond in the compound and its shape. The infrared spectrum of the solution of nitric acid in sulfuric acid shows a strong absorbance at 2350 per centimeter cube. This absorbance also present in the spectra of nitrile salts, but is not present in that of nitric acid in the absence of sulfuric acid. So it means that we have to use sulfuric acid and also the presence of nitric acid in order to have the same absorbance. The same absorbance means that the nitrate can react with the benzene. It is also identical to similar absorbance of the carbon dioxide. Carbon dioxide and nitrate are isoelectronic linear molecule, so would be expected to have similar infrared spectrum. We will discuss infrared spectrum later when we are into the chapter of analytical. And then various physicochemical data show that when one molecule of nitric acid dissolves in concentrated sulfuric acid, 4 particles are formed. The freezing point of liquid is lowered if substances are dissolved in it, and the amount of depression depends upon the mole ratio of the solute to solvent. So this one are the process. When sulfuric acid reacts with nitric acid, this one, the nitric acid will become nitrate, and then H2SO4 will lose its hydrogen atom, and then so this one is the strong electrophile. When reacts, it's like this. The protonated nitric acid then loses a water molecule, is then protonated by another molecule of sulfuric acid, and then it's become like this, so combined. The nitronium ion then attacks the benzene ring in the usual way, forming the carbocation intermediate. This one is the intermediate process in which all A-level students should know the intermediate diagram of nitrobenzene. This one, we know that NO here is NO2 positive. It means there is a positive ion cation. So positive, let's count here. Nitrogen, imagine we know that nitrogen has 5 electrons in the outermost shell. These 4 electrons of the nitrogen already occupied with the oxygen. That makes this one becoming unstable in the presence of 1 electron. And then when this one benzene make the active covalent bond with the N, and then that makes the electron of the N is being taken by the O. Then it makes the hydrogen go out. The electron is being taken by the benzene, the pi electron. And then this one, N plus, we know that the electron is already taken by the oxygen. That makes the oxygen has an excess O minus and then N plus, and then this one will become NO2. This is positive and there is a negative. And then once it is already, and then there is a formation of nitrobenzene. Okay, before we continue this process, I'm going to explain using different textbook. We know that if only studying from one textbook will not be enough, so we have to use two different textbooks. One textbook explains the other. Let's see this one. This is the nitration of benzene. This made from mixture of concentrated nitric acid and concentrated sulfuric acid. This is the process just like before. The nitrating is reflux. Now, this one reflux. So the process is reflux with benzene at about 55 degrees Celsius. So we know that this one in the previous textbook, we know that it is temperature less than 55. What does it mean? It is, other textbook explain that it has to be under reflux. Reflux is the process similar to simple distillation. The difference in reflux, there is no loss of any liquid molecule, any liquid particles. So the liquid particles will heat it and heat it and heat it again until it becomes this one, nitrobenzene. And then this is the simplify of the intermediate process. So NO is similar to the previous textbook, and then there is hydrogen taken, and then this is reformed. Let's see the explanation. In stage 1, in the mechanism, the electrophile NO2 positive is attracted to the high electron density of the pi bonding system in benzene, just like in bromine and chlorine. A pair of electrons from the benzene ring is donated to the nitrogen atom, as the nitrogen atom has less of electron to make it stable, and then forms a new covalent bond. At this point, the benzene's delocalized ring of electrons is disrupted. There are now 4 pi bonding electrons and a positive charge spread over 5 carbon atoms. So this one is the meaning. There are 4 pi bonding electron and a positive charge. This is positive charge spread over 5 carbon atoms. So this 1, 2, 3, 4, 5. However, the full delocalized ring is restored in stage 2 when the CH bond breaks heterodically. Now, this one, I know that you still remember the difference between homolytically and heterolytically. Homolytic fission or homolytically, it means the formation of free radicals. But heterolytically is the process of breaking a molecule into electrophile and nucleophile. Both electrons in the CH covalent bond go into the nitrobenzene's pi bonding system. Hydrogen leaves as hydrogen ion. There are now 6 electrons spread over the 6 carbon atoms, so the chemical stability in the benzene ring is retained in the substitution reaction. The further nitration of the nitrobenzene produces 1,3-dinitrobenzene. How to make further nitration? Then the process at 55 degrees Celsius and under reflux longer time. It will longer time and excess of nitric acid become 1,3-dinitrobenzene, and then finally all the three occupied become 1,3-trinitrobenzene. It is unlike the atom donating methyl group in the methylbenzene, or later we study in alkylation. It is also different from bromination of benzene. In bromination of benzene, the position of the benzene is substituted in the position of 2, 4, and 6 of the bromine. This one, position 1, 3, 5. Okay, let's go back to the first textbook. Okay, this is the process. This is too detailed. It may make you confused. So better to use the simplified. This one. This one is permitted in A level. Okay, let's see this one. Next. Now, there are 3 types of nitrobenzene. This one is trinitrobenzene, and this one trinitromethylbenzene. I guess I know that you still remember this one, trinitromethylbenzene. Why nitro and then methyl and then benzene? Because the methyl is more electro than more powerful the root group compared to the nitrate. And then there is a trinitrophenol, or called as picric acid. And then this one, these 3, they are called as 3 powerful explosives that are polynitro compounds. This is the TNT that you usually ever heard. And then also via subsequent reduction, nitration is important route to aromatic amines, which are used to make a variety of dyes. In the topic 27, we are going to study this one in a few more weeks. Okay, so this one, only 1 nitro is added or substitute in the benzene, not 3 position in the position of 1, 3, 5. In this one, how can we determine which one is position number 1? We know this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then this one next. So this one will become dyes. Tomorrow I'm going to explain again for the third part of the substitution in benzene molecule. It is with alkylation.